Well, g'day, Max there again. Welcome back to the shop. So today we are going to make a pair of lathe spiders. So a lathe spider, to the uninitiated, is a tubular attachment that secures to the end of the headstock spindle on the rear of the lathe, and it's a support for when you're machining long bars and whatnot. So I have got a piece of hollow bar set up in the saw, so we'll get started. So if you're wondering why there's a steady rest hanging off my tailstock, that's probably the next job. And if you're wondering why there's a scraper perched sitting there on the end of the bed, that's an upcoming job too. But this is just something I'm playing around with in my spare time. This is the lathe bed that I was going to grind, but in the interim, I'm going to do a scrape across the entire profile of the bed. Then we'll make up the measuring gear along the lines of a Kingway tool. We'll take some measurements and we'll go from there. So this is the drawing of the one for the JFMT lathe. Of course there'll be holes drilled and tapped in this section here on them both. 120 diameter, 75 long, and this is the one for the Herron, 120 diameter, 95 long. So we'll get a piece of material cut off in the store. What's the combined length? Is 170. So we'll chop a piece off 180 long. Bit of a firework display there. So that's our finished OD 120. We'll get it faced off. Get a boring bar set up and then we can do our bore. That took a fair bit to come off. That was the previous saw cut was pretty crooked there. So OD's done and yeah, we'll get it bored out. $81. Okay, that's that diameter finished. So we have a step that goes a fair way down. I'll show you on the drawing. This material is E470 or Euro norm hollow bar. So we've just done this area, this bore here, 81 mil, which is the ID of the spindle of the JFMT lathe. So now what we'll do is we'll do this bore here, so that's got to be 96.97. So that's our material there. It's a carbon manganese hot rolled low alloy steel. So you can case harden this stuff and you can weld it. 9 thou. I think we'll let that go at that, because yeah, there's a 1.5 thou taper on the bore, so it's slightly smaller at the front and we're about 1/2 thou under at the rear. So I'll just have to polish that taper out with a bit of emery. If I take a spring cut on this lathe the way it is at the moment, the chances are it'll overcut it. So we'll err on the side of safety. We'll just break this edge. Small chamfer, and I'll just put a small chamfer on that inside edge as well. Okay, beautiful. check our size. I went away from the inside micrometer and went to dial bore gauge. These are a lot easier. So we're going for 3.8177 plus or minus 4/10. This is set on 3.8177. So we got plus or minus 4/10. We're pretty well probably minus 1/10 there. Bang on size there. So we're bang on it there as well. So you do see a lot of micrometer squeezing on YouTube when people try and get their size on camera, but dial bore gauge does not lie. Best way to do it. Okay, so what I can do now is turn this lathe off because it's noisy. I'm going to spin this over and I'm going to do the exact same thing on the other end. The only difference will be this bore and the inside bore are slightly different dimensions, but we will end up with the same result. So I don't think there's any point me showing that. Might get a couple of clips in, maybe. Yeah, we will. So we'll get the other end done, then we can get it chopped in half, faced off, and then the ends, we'll get our drilling and tapping done. What are we, nearly 10 to 11 in the morning. She's starting to warm up. It's already 40 outside. And the shop here, what are we, 48 or 100 Fahrenheit. So, wouldn't surprise me if we get 44 outside today. If we do, temp in here may come up another 1 degree. So, see what happens. Well, we've only got a couple of thou to come out the bore on this one and we're good to go, but it's a bit too hot to get a accurate measurement. Must be starting to warm up outside. Yeah, we hit 40, 100 and what's that, 104. Doesn't actually feel that bad in here. Well, yeah, while that's cooling down, maybe I'll go and round up, see what materials we can use for the steady rest riser that we have to build. Start of the video, you would have seen the steady rest hanging off the tailstock. I want to use, that's the steady rest off the JFMT, and I want to be able to use it in this lathe. So I'll go see what materials I've got kicking around while this is cooling off, before I do the last cut in the bore. But like, just seen the thermometer, like it's 40 degrees centigrade here in the workshop, so outside, God knows, it'll be 4 or 5 degrees, maybe more warmer. I'll put the temperature, the thermometer out there in a minute in the shade, and we'll check it. But in my workshop here, I can open up 4 doors and there's a light breeze, and you don't, when you're actually on the machine, you don't actually notice the heat at all. You get a nice cool breeze comes through the doors, It's absolutely beautiful. Anyway, while that's cooling, I'll source some material for our other project, and by then we'll get a measurement, take our final cut. Looks about 41.5 outside. The breeze is coming now, so that's cooled things off. Oh, okay, well that spider that we're machining's cooling down. I was going to go searching for some thick steel outside, but it was too hot and everything you touch is red hot, so just knocked out a few other jobs that I had in a backlog. Just convert a couple of half-inch British Standard Fine bolts into 7/16 British Standard Fine. Make a plunger as per sample. Make a nut. 7/16 British Standard Fine as per sample. Make this cam ring as per the sample. That's the sample, and that's the one I've just made. So let's get back onto our spider. I'll give the guy a ring, he can come and pick all this up. Okay, we're back onto this job. Our part's cooled down now, so I'll show you something. I've seen in the past people really struggle to set up their dial bore gauges, and the guy showed me this method a long time ago, and I've used it ever since, and it just makes it so easy and it's so obvious. So we've got our mic set to 3.7 37, which is our target size. I'll put you in the stand and I'll show you then how I set the dial bore gauge. So we've got the foam in the casing here. Let's take advantage of it. So we use the foam the foam actually supports the bore gauge. So we can put the bore gauge in the mic, put our finger just to support the end, and then just roll it through. We just need a slight adjustment. How easy is that? I see people try and hold them, and I've even seen one person hold the mic while the other person holds the bore gauge and fumble around. But use the foam, sit it down, and just walk it through. And also don't forget to take note of your number, the little counter for your revolution. So we're on number 2. Let's go and measure our bore. So just let it drop down. So we've got about 5.5 thou to come out front here. Our size would be there. The counter's on the 2, but we're undersized, so she's coming around to 5.5 thou to cut out. We'll come down the other end because we know we're boring a taper. Just shy of 4, 3.5 to 4. We'll take that as 4 thou. The needle jumps around because it's a 10th indicator and it's picking up all the coarse machining marks. So we'll take a 4 thou cut, and that should just leave us a bit to emery out to take the taper out, same as what we did on the previous one. Just adjust you up a bit. So we got just over 1,000 undersized here. It's a bit more than what I want to polish out. So in the middle of our bore, we're pretty well bang on. Let me get you at a better angle. Hopefully you can see that. So at the start of the bore, where we know we're going to have to polish something out, we're about 1,000 undersize. So we'll go to the middle. Well, we're still undersized, about 1/2 undersized, so we'll go to the end of the bore. We're probably 1/2 over, which is the max limit of our tolerance. So it's just a matter of polishing a little bit off the front of the bore here, well, from midway to the front. About 1/1000th of an inch. So I'll break these edges first. Just a little ring around there, that's a tad on the small side. Right, that's got it. Let me swing you over a bit. Sorry, I didn't realise you guys were on a magnified lens then while I was doing that bit of polishing. That's right where we need to be. And of course we're probably half a thou, well, a good half a thou oversized at the rear of the hole, but that's fine. Come up the middle. We're right on it, right on size. Come up the front, and that's it, right on size. The dial bore gauge, don't lie. Okay, so I'll get a tool set up and I'll just skim the outside to match the OD we already have. And then this, we'll get her out and get it cut in half. So we'll come up, match this diameter, and then turn this rusty bit off. We're running on 350 RPM. Throughout the whole job, except for that bit of polishing, was 480 RPM. So I'm just going to touch off on here and look at the number on the cross slide. And I'll do it in 2 cuts. let's get her out, and right there should be 100 mil long. Yeah, right there, that's where we're going to chop it in half. If I had a parting tool big enough to go in this lathe, I'd just part it off. So when we part this in half, we should break through right above this join where these two diameters meet here, if we've done everything correctly. Just got to make sure our parting tool's going to have enough stick out. So we'll just get it. I want to keep it as minimalistic as possible what's hanging out. Alright, let's get it done. I just got a tray to catch the excess coolant that's going to come off the front of the lathe. What happens, it's I put a tray in down here and it just keeps the splash from coming back towards me. Just an old baking tray I put there so the coolant that splashes down just gets redirected back to the lathe. No problem whatsoever. So we broke through in the right place, right in the middle of where these two different diameters here meet. So we'll get both halves faced off. So the tailstock chuck here, perfect for this application. I'll put a link in of the videos when I actually made it, in case you guys want to make one. put a good radius or chamfer on this edge here, because this will be an exposed edge hanging out the rear of the lathe. The inside can just have a normal chamfer. Just slow that down a bit. And a bit more. It wants to be a bit chattery, that one. Bit bigger. Okay. Okay, that's all it needs. It's a functional part for a machine. It's not a trophy. So this will slip over the spindle of the lathe. There'll be a couple of locking screws at 90 degrees, and on the end here we'll drill and tap in 4 locations for some bolts to screw through. So the one for the JFMT, once I have the 2 grub screws drilled in at 90 degrees, so this will go on there, and you'll be able to access the 2 locking grub screws, and yeah, we'll have the 4 holes drilled and tapped for the bolts. I have to make this one detachable, so the grub screws have to be easily accessed, because when you open the door won't clear, and I don't want to enlarge this hole. So that's that one. Nice fit too. Now the other one, locking screws 90 degrees, the same deal with the bolts. However, on this one I've just got to modify the rear cover. So this has a little insert here. I'm going to take that out and I'll just bore the hole in the cover bigger till the cover slips over this one. So this one will be a permanent fixture. Once it's on, it's on. Well, I think we'll button this one up here. So next video we'll get these completed, as we're sort of going to run out of time on this one. I am probably going to stick with the longer format videos for a while. A lot of people prefer to see the whole process and everything shortcutted like a lot of videos are. So I mean, just means you got to fast forward or whatever. So that's the way I'll do it. Well, for some of them, you know, there will be some that will be shorter, but it depends on what I'm doing. So anyway, enough of that. So anyway, cheers, thanks for watching, and hopefully see you next video.